Hello, welcome. This is our Path to Publication webinar with iMotions and Dr. David Hurwitz, who we are very excited to have today. Thank you so much for joining. Just some housekeeping notes before we get started. I know we have a ton of stuff to discuss today, so I want to just get through the sort of like more practical things before we, Dr. Hurwitz and I have a nice discussion about transportation and simulators. But this webinar is being recorded, so it will be sent to everyone who's registered tomorrow in about 24 hours. So if you need to jump off early, that's no problem. You will receive it in your inbox. And then if you want to send the link to other people in your network who want to watch either right now or they want to join and watch later on replay, they are welcome to do so. As long as they find the registration link, they will receive the recording tomorrow. So please send it to your colleagues if they're interested and didn't have time to join right now. And then we are also going to have an interactive discussion with David Hurwitz, but we are also open for a Q&A after the more like interview style discussion afterwards. So if you have questions for Dr. Hurwitz, please put them in the chat and we will get to them during the Q&A. But without further ado, let us talk about what we are actually going to be talking about today. So we have Dr. Hurwitz here. He is a professor of civil engineering at Oregon State University, and he is the director of the simulation lab that we are going to be talking about today. It's very interesting, very innovative laboratory. So he has also been a longtime iMotions client, and he's going to talk a little bit about his journey using iMotions, researching and publishing within transportation research. And then, as I said, we'll have a Q&A. So welcome, David. Happy to have you.
A pleasure to be here.
So great, I'm gonna just do a little bit of an intro to iMotions. There might be some people on the call here who don't know so much about iMotions, so I wanna give 2-3 minutes, really quick overview, high level of what we do as a software company so that you kind of have the background or the sort of conceptualization of how you could maybe use it or get inspired by what Dr. Hurwitz is doing. We are a global software company. We have been in business for almost 20 years. We were founded in 2005 and we have offices all around the world, and we help our clients do what we call advanced human behavior research. Now, what does that actually mean? It can mean a lot of things. We span a ton of different application areas from academia, like we're going to talk about today, and transportation research, all the way to consumer insights, human factors, UX, etc., by incorporating biosensors. So biosensor research is a way of using sensors that are wearable or remote to capture the sort of non-conscious signals that our bodies are sending when we are reacting to something, whether it's an experiment, a stimuli, a situation, an environment. Complex simulations, for example, could be a way of immersing oneself in an environment, and then we are able to help you extract the data from biosensors, synchronize them, and analyze them in one platform. So we basically streamline this research. As you can imagine, biosensor research can come with a lot of cumbersome aspects in terms of data capture, because you have, for example, you have your eye tracker that's sending a stream into some sort of software. You have facial expression analysis. You have maybe skin conductance, which measures sweat from your skin. And all of those data signals need to be compressed, consolidated, and synchronized so you can actually get data that makes sense. So we can connect those sensors and design the studies and present a stimuli, analyze, and export data all in one platform. So this is kind of what it would look like if you were working with a simulator setup. This is a 3-screen sort of immersive setup, and you can see on the bottom underneath the screens, you can see that there are like different signals happening of raw data across the way as you're watching the participant in a study. So that's basically the overall setup for iMotions, and there's a ton of different ways that you can apply it, but let's not go into that too much before I hand it over to David and we'll have a nice discussion. So we power both academic and commercial labs, as you can see here, one of whom is Oregon State University. And we are really here to make your research easier and help you publish faster. So this conversation is going to be about how you can do the best biosensor research possible with your setup, and then how we as knowledge partners and software partners for you can really help you get that data to publication faster, and all of your research questions can get answered, hopefully. Can't promise too much, but hopefully most of them will be answered with this kind of technology that we offer. So David, I'm actually going to give you presenter access. So I know you have some nice slides for us. So I'm going to change presenter here. And I would love to just ask you how you first got started and interested in research. So I'll let you take it over with the slides. Yes, perfect.
Beautiful.
Yes. So yeah, tell me about how the genesis of your ideas of working with transportation research got started.
Yeah, sure. So really for me, it was threefold. It began with experiences in the classroom when I was an undergraduate student studying civil engineering and first being introduced to transportation. Two notable mentors in my educational path, Dr. Kathleen Hancock, who taught my very first engineering class ever when I was a freshman at the University of Massachusetts Amherst. She also taught my first transportation course in my junior year. And then Dr. Michael Mulder, also a professor of transportation engineering at UMass. He taught my first graduate level course in traffic operations and design. And so this really sparked my interest in the domain, so much so that in my junior year, as I was trying to explore what I wanted to do when I grew up, I reached out to Dr. Hancock and asked, gosh, could I participate in some undergraduate research? At the time, she was leading UMass SAFE, Traffic Safety Research Lab at UMass, and I joined the team in the middle of my junior year, and gosh, haven't looked back since. And my third formative experience in the transportation domain was interacting with professional societies, specifically the Institute of Transportation Engineers, where I joined the student chapter at UMass, participated in section activities in the state of Massachusetts, and then district activities in the New England section. And that's all she wrote. I haven't looked back since.
Mm-hmm. New England, Massachusetts person after my own heart. I'm also from Boston, so I feel that. Great that you got inspired by researchers to continue on this journey, but I would love to just skip forward a little bit ahead a couple years to now where you are at OSU and the process of establishing this very interesting lab that you're going to tell us about. How did you get started and how did you like get the funding? How did you really make this land so that you could conduct the kind of research that you're interested in?
Yeah, sure. So I love and have always been attracted towards laboratory-based experimentation. The ability to control variables of interest, to develop explanatory mechanisms. Those were the types of research experiences that I really gravitated towards when I was coming up through my educational pursuits. So to do something similar at OSU, we needed to generate resources so that we could purchase the types of equipment and spaces that would allow me to perform experimental studies. And so there were a variety of resources that we leveraged. Those included monies attached to my startup package, opportunities through our College of Engineering, opportunities through a faculty endowment that I was granted for a couple of years, and then other sources. Private philanthropy ended up playing a pretty significant role in the development of our laboratory, both through individual families as well as charitable trusts, and then the small monies that are generated in excess when conducting active research. And each one of those elements helped contribute to the initial capital investments in our very first lab component, the passenger car driving simulator, all the way through some of our most recent innovations and laboratory equipment in terms of the commercial motor vehicle simulator.
Mm-hmm. Okay, so it was a sort of gradual process. All of this funding didn't come at once, right?
Oh my gosh, no, that took a little less than 15 years. That's the width and breadth of every potential source that contributed to the construction of our facility. And so once you have the money, then gosh, you've got to put it to use. And again, this is more of a process or a journey rather than a destination. I grabbed a few images throughout the course of the lab's evolution over the last 13 years, starting from a pile of wooden furniture in 2009, construction of our first temporary space, to moves around campus and across campus, to our current more permanent location, with the most recent implementation being our biometric suite of sensors in our iMotions data acquisition platform. And then when we talk about sort of the timelines attached with putting some of these tools to work, they're not inconsequential. So I started here at OSU in 2009, and before I even landed on campus, I was working with senior colleagues to develop our sole source paperwork that allowed us to purchase the very first driving simulator version that was installed and functional in and around 2010. And it took us until 2013 to generate our first published experiment. And so these are a couple of screenshots from that original version of our passenger car driving simulator, this particular equipment produced by RTI on the simulator side of things. And that first experiment was an evaluation of dilemma zone conflicts and behaviors as modeled in a simulated environment. And so what we're seeing here are individual road users being exposed to different durations of yellow intervals as they approach a signalized intersection and their resulting choices. And this model shows that when drivers are closer to the stop line and the light turns yellow, they continue to proceed through the intersection. When they're significantly far away from the intersection, there's a decision point between those two extremes where drivers can make different decisions. Even the same driver can change their opinion to clear or stop at a signalized intersection, a problem that's confounded transportation professionals for quite some time.
Very cool. Yeah, so it was a long process to actually get to that publication stage, but you had the vision and it kept going. But yes, so you mentioned biometrics a little bit and performance measures, and I would love to get into that also because that's what our expertise is at iMotions. But I would love to hear about how you're incorporating sensors and performance measures using biometrics, including, if not iMotions, to assess driver performance and interactions between all of the different elements that you study. Because what's also very interesting about your lab is that there's 4 different elements or 4 different simulations that you can network together, right? So how do you actually use that network structure for human in the loop studies, for example, and testing performance measures of kind of physiological responses and psychophysiological responses?
It's a wonderful question. So why don't I maybe start by describing the lab in a little bit more detail. And so our laboratory footprint includes 4 different styles of human-in-the-loop simulators. And so we start in the top left. That's our desktop development simulator. And so simulators of this construct can absolutely be used for research to deliver meaningful findings and outcomes. In our lab, we use that platform to build experiments. It's a little more efficient. It's one server that operates that system. So it allows us to code and model virtual worlds and design dynamic interactions, and then compile and run those environments in an efficient fashion. So that's where we build our experiments. And then we collect our data in one of 3 larger scale simulators. In the top right there, you'll see our full scale passenger car simulator. Bottom left, you'll see our full-scale bicycling simulator, and bottom right, you'll see a quarter cab heavy vehicle simulator. And so we're working with any individual modes, or we're putting those modes into interactions with one another. So just a couple of interesting features in our lab: our passenger car and our commercial motor vehicle simulator both have digital instrument panels, so we can manipulate the information that's presented to our drivers. It also allows us to study things like assistive driving technologies and automation at different levels. And so both of those vehicles can operate at different levels of automation. A second characteristic that's pretty interesting about our lab is that we can conduct multimodal network studies. So a live subject in our passenger car or our bicycle or our truck simulator can interact with avatars of one another in real time. And we can collect some very nice information from these simulators, and any input that the driver places on the system: steering wheel, brake pedal, accelerator, that can all be recorded and time-stamped at a rate of 60 hertz, so 60 measurements a second. It'll give you things like the speed of the vehicle, its lateral position, the headway between a lead vehicle or a following vehicle. All of that's useful, but it's not enough to explain all of the nuances of user behavior and decision making that we want to access to design safer and more efficient systems. And so pretty early on, we recognized that we needed to add additional sensor technologies to get a more robust picture of user behavior in all of those different modes. And so what we're looking at here is our current footprint of biometric data acquisition. So we've been using iMotions in the lab for a number of years now to acquire information initially in galvanic skin response. That was the first sensor that we adopted in the lab. And the results from those applications in our bicycle simulator studies were so compelling that we pivoted towards also acquiring visual attention information. And so we're using Shimmer 3 Plus sensors for GSR and Tobii Pro Glasses 3 for visual attention, all acquired through iMotions platforms. And I've grabbed a couple of screenshots on the user interface from those particular systems in our lab. And so this data gives us information about where our subjects are looking and when and for how long. It also gives us information about the relative stress that they're experiencing as they interact with different risky scenarios in the built environment, as well as with novel infrastructure. I'm a civil engineer by training, so folks in our lab are fascinated by the ideas of designing safer and more efficient roundabouts, safer and more efficient, more intuitive signalized intersections, any place where multiple users have to interact with one another. Those are parts of the roadway infrastructure that we like to model in the lab to try and innovate based on user response.
Right. And what's also really interesting about what you've told me about your lab is that, you know, the kind of user interactions can be as complex as a biker interacting with a truck driver, right? And then all of those performance measures, like the visual attention and the relative stress, can be measured simultaneously from both angles, for example. And I just think that's super cool.
Yeah, and so one of the threads of interest in our group are mixed mode interactions, bikes and cars, bikes and trucks, cars and trucks, so on and so forth, pedestrians and all of the above. We're fascinated by those interactions. We think they're a little more complicated, and they're highly correlated with overrepresentation in crash outcomes. And so we're trying to understand how to smooth out the interactions between those multiple system users. And so one of the pivots for us, given that the network capabilities of the lab and our interest in lab experiments, was to be able to collect biometric feedback from both users as they're interacting with one another. So in order to do that, we had to scale to multiple data acquisition systems. And so we have two full suites of equipment that we can install and calibrate on, say, a passenger car operator and a bicyclist to acquire both of their sets of visual attention and stress and so on and so forth. Most recently, we applied that design to examining bicycle rolling stops. So the interactions of bikes and cars, stop controlled intersections, whereby under trucks, the bicyclist can treat the stop as a yield condition. That's a relatively novel law, first originated in Idaho in 1982. So it's been around for a while, but in the last couple of years, it's been adopted in another 8 state DOTs around the US. And so that's a topic of a little bit of interest, which helped us leverage this particular capability and equipment configuration.
Mm-hmm. That's very cool. Yes. In terms of having an impact on these transportation safety measures and infrastructure, what's also really great about a simulator, as you can imagine, is that you can control for those elements that might be dangerous in the real world, right? And being able to actually measure human performance and reaction times and, visual attention during those stressful situations without actually damaging anyone is great. So I would love to hear about, some of the other impacts that this lab has had on safety and infrastructure.
Yeah, sure. So think about a few recent outcomes from the laboratory. We'll pick a couple of examples here. One revolves around the interaction between bicycles and signalized intersections. So one open question is, gosh, when a bicycle approach an actuated traffic signal, are they in fact detected by the actuation systems? And so working with partners in Portland, in Salem, Corvallis, in Eugene, Oregon, we helped extend the development and evaluation of blue light bicycle detection feedback systems, which turn on a little 2-inch diameter blue light when a bicycle is detected at an intersection, indicating to those users that a green indication is coming and that the intersection sees them. And so that was quite a bit of fun. We also had the chance to collaborate with the city of Portland on installing the very first bicycle signal countdown timer in the United States, and in performing in-field evaluations of its operation. And I'm excited to report that, gosh, that system's been scaled to several dozen individual intersection approaches in the city along Southwest NATO Parkway.
Great,
Here's
congratulations.
yeah, for sure. A wonderful collaboration, to be sure.
Mhm.
Here's a second example of an outcome from the lab's works in Washington County, Oregon. Here we're looking at technologies for passively detecting bicycles and pedestrians at a particularly long street crossing with a median divided island. On the left, you're looking at the outputs from thermal detection, tracking the positions of bikes and peds all the way across the roadway. On the right side of the screen, you're looking at an optical solution that's doing something similar. And so we help the county evaluate the relative performance of these types of systems to track pets and bikes in real time. With those data sets, we're able to do some really compelling stuff in terms of dynamically adapting the phasing at this location. So you could imagine a scenario where a pet or a bike perhaps pushes a push button, placing a call for service on the system, then sees a gap in the conflicting stream of traffic and maybe jaywalks, maybe crosses against the pedestrian signal. In those situations, if we can track them all the way across the roadway, we can then drop that call for service and prevent our vehicles from being stopped for what some people would call a ghost pedestrian phase. And so that's one use case. Another on the safety side of the equation would be if a late entering ped or bike steps off the curve at the moment the sign starts to flash, we can extend that interval to help carry them across the right of way before they end up conflicting with an active vehicle movement indicated by green. So that system has been evaluated over the course of the last couple of years. And again, we generated positive performance measures, and it's been scaled to adoption at other locations in the county.
Super cool.
Yeah. Last example, this one's for the Oregon Department of Transportation, and this was based on laboratory experimentation. So at intersections where we have high volumes of peds and bikes, we have concerns with right vehicle turning conflicts, in particular permitted right turns. And so the mission here was to try and develop an improved understanding about how we could mitigate turning vehicular conflicts with through moving bikes and peds. And so in about 2009, the flashing yellow arrow was adopted in the Manual on Uniform Traffic Control Devices in the United States. And that stipulated that we could use the FYA as an indication for permitted movements in the left turning and in the right turning direction. However, the adoption of the FYA for permitted right turn movements was significantly slower than it was for the left turning comparative. And so we wanted to evaluate, could we improve driver decision making, their visual attention, their risk and hazard perception, and their yielding rates if we introduced this FYA in a laboratory setting. And the results from the experimentation were incredibly positive. We saw increased detection of ped and bike movements, as well as increased yielding rates. And they were so positive that they reinforced choices that our state DOT had been moving in demonstration and pilot studies, and resulted in a formal adoption of those signal heads in the 2022 signal design manual.
Nice, that's really cool. And for this last study that you mentioned, you used iMotions to collect and analyze the data. Is that correct?
Yeah, we sure did.
Yeah.
And so our visual attention data, which was incredibly important in that study, but really in most of our safety investigations, the, the the resulting decision making, you can see that from the simulator. But why those decisions are occurring, in our opinion, we really need a variety of different biometric measures to help us develop those explanatory mechanisms. And so it's been invaluable for us in terms of interpreting the more traditional traffic engineering performance measures, which have lots of value, but don't necessarily lead themselves to robust explanations.
Hmm. Right. And yes, at iMotions, our product specialists, we always like to say that you can see the what without iMotions, but the sort of why it becomes richer with iMotions or with biometric sensors and data, because you have that, like you still need to understand why folks are doing what they're doing, and you can ask them that, you can observe their behavior, you can watch them, but getting to that sort of minute non-conscious level of what they're actually looking at and how stressed are they and is their heart rate going up can give you another layer that you might not be able to decode with sort of more, like you said, traditional methods. So you need to be able to be still a researcher. You can't just like use, the data as gospel. You need to be able to interpret it, but it helps along in getting those nuances that are really to make the difference in your research.
Well, in the way we think about it is really we try and triangulate the truth. And so we get certain measures from our simulator systems that have value. We get certain measures from our biometric systems that have value. And then we typically do some form of qualitative pre and post investigation, either survey based or interview based. And we get some value from that as well. And if we start to see consistency across those data sets, our belief in why things are occurring becomes stronger. Yeah.
Right, exactly. Yes. So coming to this question here on the slide, what you've just mentioned, your studies involve a lot of data, and your lab is quite sizable too in the number of studies that you're able to handle. So I'm guessing, and we've talked about this, that students and user communities play a big role in how you're able to produce this research. Can you talk about how you involve students, postdocs, PhDs in your lab?
Yeah, for sure. And I can't overstate how important students are in our endeavors on the research front. They're the most important people in our laboratory, and they're intimately involved in all stages of our experimentation. So when we think about conducting laboratory investigations, in our group, we tend to start with robust literature reviews. We want to know everything that's been done and all the ways that it's been pursued. What questions have people generated consistent responses to, and what gaps in knowledge exist in the domain? And we really try and hone in on those gaps and then map the gaps in knowledge to the importance of resolving those gaps in the real world. What practical applications could answers to those questions yield the engineering community? We translate those gaps in knowledge into research questions that are experimental in nature that we can generate quantitative data to support or refute if our experiments go well. We then design experiments aimed at filling the gaps argumented by those questions. We acquire data with a variety of tools, some of which we've talked a little bit about already. We apply acceptable statistical paradigms to the experiments as constructed, meeting assumptions, and then we try and interpret those results to the best of our abilities, and we share the findings with the public, the research community, with other laboratories like ours, trying to move the state of the practice forward. That's a little bit of a long-winded way of saying we lean into the scientific method in all of its forms. We're experimentalists by nature. It's the kind of work that I enjoy the most. And so the students in my group are involved intimately from the very beginning to the very end of that process.
Great.
In
And
addition to
you
that,
mentioned, yeah, sorry, go ahead. I'll ask you something afterwards.
sure. So in addition to that, we also try and develop techniques that might be helpful to either increasing the efficiency of our lab and how it functions, or that might be useful to other researchers in the user community. And so we have benefited from the thoughtful contributions of other universities and with the vendors of our equipment. And we've developed a couple of maybe novel, but at least efficient approaches in our laboratory. So one of the things that was super important to us in terms of leveraging biometrics to the greatest extent possible was to synchronize the biometric data acquisition with our simulator output. And so in collaboration with the support team at iMotions and the folks, our simulator vendors, RTI, we helped figure out a coding scheme that would allow us to do that in an effective way. We've applied some pretty slick techniques using simple Python code to extract data directly from our simulators in a way that's effective and efficient. And we've also pivoted towards other technology solutions. So we started with 2 acquisition platforms from iMotions, and we quickly found out, gosh, we were collecting more data than we could post-process in an efficient way with just 2 channels. And so we also leveraged the student data reduction licenses in order to allow multiple students to work on the equipment at the same time. And so we have individual towers in the lab that students can work on, but also laptops that they can check out. So we can have lots of folks reducing data simultaneously, and that's been invaluable to our process.
Cool. Let me just elaborate a little bit more on the student licenses that you mentioned, because I like the way you conceptualized it, kind of like a library where you can check out a computer, because we have a system where all of your studies that you prepare and collect data on can be on a one core computer, right, or a license that is on a laptop or a desktop in our lab platform. Something else that's different if you want to collect online data, and you can see our website if you want to learn more about that. But then you can have your students be able to work on the data analysis process on another license that is like connected to the studies from your core license. So it actually creates a lot of flexibility. Students can take them home, they can work on their own time, and they don't have to be cumbersomely tied to coming into the lab and sitting in that laboratory if they want to work on the data reduction process. So I think it's great that you are using it to the full capacity, because you also have a very productive lab where you have, you know, students and PhDs coming in, and like over time you're also able to switch those licenses out for new people coming in. You know, if people are on vacation or they're done with their studies, you can switch it out to new people and teach them all.
It's been immensely helpful for us. So I think we've scaled to at least 3 data reduction licenses now, and we've added tools to the toolkit as the demand for additional channels has presented itself. And so the flexibility has really helped us execute our project workload in an efficient fashion. Because we've made them mobile and put them on laptops, it's also a good excuse to give undergraduate research assistants a chance to dip their toes in the water of considering what biometric information means and what it means to conduct research. And that's been a really nice value add for our group as well.
Very, very, very great. And I love hearing students coming back and saying that they're excited to learn about this. So yeah, to move into the more publication and sustainability question with your lab, because it's very inspiring that you're able to do all this research. So I actually want to hear about how you actually make it run all the time, because there's lots of costs involved, right? And if you're employing students and researchers, and you also have all this technology and simulators to support, how do you actually maintain the funding? And then we'll talk about how you publish using that process afterwards. But let's talk about sustainability.
Yeah, for sure. And so when I think about the longitudinal sustainability of any laboratory, using ours as one small example, you know, our college has a strategic plan. One of the elements of that strategic plan is to be a partner of choice. And that was something that landed as particularly authentic to me. And so we've kind of operationalized that vision in a handful of different ways. And some of these may seem immensely obvious, but they're all non-trivial. And so sort of the first key takeaway to me is do excellent work always. And so if you produce good outcomes for the students in your group and the agencies that provide you the opportunity to work with them, whether they be, you know, small municipalities, state or federal agencies, private endowments, industry, so on and so forth, there will be continued opportunity to serve those interests. Especially early on, we tried to emphasize quality and then scale quantity over time. To me, you have to be excellent at what you do in order for others to want you to be part of their team in their process. One comment that some close collaborators have made about our group is that our team, from the undergraduates all the way through to myself as the PI in the lab, we deliver on our commitments. So when our dean says that we're going to do something, we in fact do. And believe it or not, that's maybe a little bit less common in academia than one might think. This is a phrase that one of my mentors way back when used to share for me in somewhat of a joking statement, but overpromise and then overdeliver. And if you do that every time, you're never going to lose. It may not be the best work-life balance argument, but it certainly produces positive outcomes within the context of the laboratory. I think this next one is probably my most important word of advice: recruit excellent students. The people are what make labs like this special, in my opinion. I think you can do brilliant work with nothing but a free application on an iPhone. The key differentiator is not the $1 million facility, it's the people operating that facility. And so if I was to give a word of advice to folks that are actively managing labs now, or maybe thinking about managing a lab in the future, pursue excellent students like you pursue funding from a prestigious grant agency or a highly ranked journal article. It's one of the most important contributions that you're going to make in your careers. Last but not least, cultivate meaningful relationships with agencies. That of course assumes that they give you the opportunity to do some work with them initially, but when given those opportunities, lean into them as best you can. Good things will come from those efforts. A second big picture idea to me was diversifying your research endeavors. And this was advice that an early mentor gave to me here at OSU that landed as incredibly authentic in my experience. And so we need to diversify in a variety of different domains. The first is the topics that we might be interested in conducting work in. And so here's an example of the footprint of our lab right now, if I was to articulate it in a handful of phrases. At the biggest bundle, we do work in operations and safety with a particular emphasis on transportation human factors in most of what we do. Within that subdomain, we have threads of work that focus on vulnerable road users in the bicycle and pedestrian space. We have threads of work that focus on the needs and abilities and limitations of commercial motor vehicle operators. We do lots of work in traffic control devices. I've always had a passion for that. That's signals and pavement markings. We're expanding our work into the connected and automated vehicle space, in particular with some of our federal agency partners. And then I've always loved the classroom, so we do a little bit of work for the National Science Foundation in the engineering education space, trying to figure out how to generation of thought leaders and practicing engineers. So the kinds of work we do, that's one bin that we have to think about diversification on. Another bin that might be worth leaning into are the methods that we employ. Today, we're talking predominantly about our human in the loop experimental capabilities and interests. And so that's one type of laboratory study. We also do hardware in the loop microsimulation in the traffic domain, where we plug real controller cabinets into tools like VISN in order to model actual signal operations in a more robust fashion. In order to validate both of those laboratory experimentation types, we do lots of different field studies, some at the instrumented vehicle, pedestrian, or bicycle level, others with remote sensor systems at the roadside. And then over the last couple of years, we've moved into the application of drones in transportation research to great positive effect, in addition to surveys, focus groups, in-person interviews, and the like. And like we mentioned before, the purpose of this is really to try and triangulate truth across multiple experimental mediums, whether it's calibrating and validating a laboratory result or helping to identify the need for a research question based on different sources of information.
Yes, and I think that is very key to talk about diversifying your sources and also like these collaborations with both academics and industry because, you know, you don't want your lab to live and die by you and your capability as an individual, right? You want your collaborators to be able to believe in the vision and keep executing this great research, even if, you know, it's not just you.
Oh, for sure. I regularly say I think I'm the least important person on my team. And so it starts from the ground up with our undergraduate, graduate students, and research faculty, as well as those organizations that we partner with. I mentioned that vision of being a partner of choice. Here's just a few examples of universities in the US and abroad that we have deep professional and personal relationships with, as well as some practicing firms that we've continued to pursue research either with federal agencies or NCHRP. Teams matter, and so we're always looking for talented, highly energetic, passionate people that want to advance the state of traffic safety in the U.S. and abroad. And this is just a few of our wonderful collaborators. And in that collaboration, we of course need to pursue funding. I think of funding as a force multiplier for research. So it is not required to deliver incredibly high quality, impactful research, but gosh, it allows you to operate at a slightly larger scale if and when the opportunity presents itself. And so here's a list of some of those agencies that we've had the pleasure to provide research services and contracts for at the city, county, state, federal, levels in the transportation domain, as well as from research organizations at the regional and national level. And so their support is invaluable in providing really opportunities for the socioeconomic advancement of students at the end of the day and to advance our knowledge in the research domain.
Mm-hmm. Yeah, and what's clear from this funding profile and also your collaborators is that you're really thinking outside the box and being creative and what kind of projects you can deliver to these partners because the questions might be vast, but you might have the capability in your labs to actually deliver on that. And I think that's true of all of iMotions customers. People working with biometric research, you all have so much opportunity to actually disseminate your knowledge and resources across a lot of different collaborations and like application areas. So if you're thinking about something that might be an interesting research question for you, like see who's out there, see who's in your neighborhood, who's in your network, and see if there's any sort of projects that could be interesting. And then who knows, maybe it becomes a long-time collaborator or funder. Yeah. So last, before we get to the Q&A, we already have some questions coming up here. So the whole point is to, well, maybe it's not the whole point, but a big part of this is to be able to publish your research, right? So I would love to hear from you, who has published lots of stuff in collaboration with your lab, and all of your researchers can probably attest to this as well, that there might be some tips or tricks of the trade. Do you want to share any of them with us about how you're able to get your research through the door?
Yeah, for sure. And so I'll start by saying, like, as it just so happens, I really like writing papers with students. It's one of the things that I very much enjoy about the academic endeavor. And so these are a couple of overarching ideas that resonated with me when I was thinking a little bit about this question. And so, I'm an engineer at heart, and engineers like to reverse engineer outcomes. And so one argument that I might suggest is to try and think about your desired outcome first. What is it that you're hoping to achieve through the course of either a sustained investigation in a content space or down to an individual product? I think if we have in our mind's eye a vision for the future that is resolved and well thought out, we can build processes that help get us there. And misalignments between the development of a research question, the scope of a research inquiry, and the desired outcome are one of the foundational problems with folks have when they try to publish their work. So that's one that's worth thinking about a lot. I've mentioned this a couple of times, but the quality of a research question has a huge impact on the potential publishability of an individual research project or experiment. If we ask compelling, non-trivial questions, we've got a better shot at generating an amount of knowledge that's worth disseminating through a peer-reviewed journal article. I think we develop those questions, we really want to be thoughtful about aligning them with gaps in knowledge. There is value in reproducing the research of others. I also think there's value in negative findings, but gosh, if we can better align our work with gaps in knowledge that have real relevance either to the research endeavor or to practicing professionals, we increase the likelihood that people are going to be interested in our work. And is it's not just developing a great research question, but it's developing a great research question that aligns well with methods and resources that you have access to. And so that's something that, as simple as it may sound, we still see people all the time misalign their research questions with the experimental tools that are available to them. And so that's worth thinking about quite a bit as well.
Mm-hmm.
And then lastly, I'd say it comes down to the selection of a journal article. And so I took a cut at the lab's CV, and here's an example of 20 journals that our group has published in over time, with an interest in a little bit of a leaning towards application-centric work, a little bit of a leaning towards air traffic operations for safety, and a big emphasis on transportation human factors. There are lots of high quality journals out there in this space. This is by no means an exhaustive list, but the mission statements of these journals tend to align pretty well with the kinds of questions that we ask in our lab and the sorts of methods that we employ. So if you're working in this space as well and you're thinking about where you might want to submit articles, here's a reasonable place to start. And the key, just like we want to align research questions with gaps in knowledge and methods with research questions, we want to align the work that we're submitting to the mission statements and the content space of the individual journals. Editors and associate editors take that part of the process very seriously. And so picking the right place to submit to can be very helpful in your process towards publishing your results.
Mm-hmm. Yes, and just to add a little bit to that, I totally agree with you that selecting the right fit is super important. And I would say that biometric research and sensor research can kind of make you stand out because it's such applied measures that these journals might actually be really interested in that they haven't heard of these methods before. But as you said, it's really important not to overdo it in terms of all of the sort of signal processing and all of the data that you can bring in. Maybe attach 6 sensors, do eye tracking and GSR and ECG and EMG. But like, let's be realistic about what methodology you're using for that specific journal, for that article that you want to publish, so that you're really like hitting it with the nail on the head. The research question and the experimental design should fit what you want to publish in the specific topic area that journal specializes in. So we said that a lot with our clients, that we don't want people to, get trigger happy almost and say, okay, cool, we're just going to add 6 streams and then it's going to be the most amazing research. No, you actually have to think outcome and what kind of data is going to be relevant.
You're absolutely right. The general advice and the model that we operate under in our group is that we try and keep it simple. Use the irreducible minimum amount of equipment, sensor footprint, data analysis, statistical modeling that is required to answer your question of interest. I think sometimes we try and employ novel methods for the sake of employing novel methods, and that's apparent to folks. If you're using tools that are well aligned with a gap in knowledge, a research question, and a reasonably accepted methodological approach, your success rate is going to increase dramatically. Even if you choose a simple solution, maybe just visual attention is all you need. Maybe the representation of stress is the cornerstone that's going to hang your argument on. Perhaps 7 sensor sets just for the sake of isn't the right approach.
Yeah, great. Thank you, Dave. I am going to launch a little interactive poll so that we can get to questions from the audience. So we only have about 10 minutes left, so please, if you have a question, now's your chance. I also want to just hear if we can follow up with you. We've talked a lot about iMotions, and I want to hear if there are ways which you would like to hear more, and we can make more of a customized setup for you. So either an intro call, we can get one of our researchers, product specialists on the phone with you and talk about your research and how biometric measures could help you. Or just if you're not interested, that's also fine. We have a customized demo also that we can show you. We can actually get your team or your research team on like a demo where it's live and you can explain your use case, and then we can actually show you in the software how you would create studies with the kind of research questions you have. So let me know if you're interested. But while I'm doing that, let me just ask some of the questions that are coming in. So the first one we have is a great one. Dr. Hurwitz, can you talk about the importance of your research in the context of smart roads and enabling self-driving? It seems like the robust self-driving algorithms will necessitate beacons on the road to indicate speed limits, traffic hazards, etc. Great question. Do you agree that smart roads and sensors embedded on the road infrastructure is required for self-driving to become reality?
Gosh, it's an exceptional question, right? And we broadly talk about this under the bins of both connected and automated driving systems. And I think the leading edge of this really is going to be in the connected infrastructure space. So it's information passing from vehicle to vehicle, from vehicle to bed, from infrastructure to vehicle, in all the different pathways that we're anticipating. Some of that's already happening right now at fairly substantive scales. So I think we underplay the value of connected systems when we start talking about these disruptive technologies. That's a reality that we're going to experience at much larger scale, much more quickly, I think. Eventually, we're going to end up in a place where automated driving is ubiquitous. But the timeline between here to there, that's a more open question. And I think that we're starting to realize that the time horizons for that adoption at scale are much larger. The potential for geofencing environments and providing complete information to more highly automated systems, I think that the commenter is absolutely right, could increase the rate at which those systems are adopted and the viability of different applications. And so our pivot in the lab and the truck simulator and the passenger car simulator being able to operate at different levels of automation is our interest in trying to nudge that tech in a way that continues to consider the human element of transportation. Even if the operator in the vehicle is utilizing a fully autonomous system, that level 5 construct, the perfect solution to connect bikes and peds and to interact in midst traffic where other vehicles are being manually automated is going to exist for a while. And so people are going to be an interface in these systems for some time to come, I think. And that's our opportunity to try and make a difference.
Yeah, I fully agree. And I would love to talk about this more, but time is limited. So we have to move on to the next question, but I'm just going to close this poll. So thank you everyone for answering. I appreciate your time. And yes, so the next question is, have you considered using a VR headset with eye tracking to run the simulations?
That's a great question. And so we talked a lot about collaborating. And so we've had a multi-year collaboration with some of the psychologists here on campus, Kristen Makuga being one wonderful example of that. So she runs a VR laboratory environment with motion capture and eye tracking. And her and I have been partnering on projects with Toxel and NHTSA to try and understand outward-facing human-machine interfaces on highly automated vehicles and how EHMIs can help peds and bikes correctly interpret the intentions of those automated systems. So we've built experiments in our bicycling simulator that we've transferred into the VR headset space with wonderful positive effect. I'm convinced that there's huge opportunities for using VR equipment in driving, bicycling, and pedestrian laboratory experiments, so much so that MJ Murdoch Charitable Trust partner that I mentioned is investing in us building a pretty large scale VR high fidelity motion capture lab right next door to our multi-modal platform. And so I couldn't agree more. There's huge opportunities there, and we're moving in that direction.
Well, stay tuned. That's very exciting. another another simulator in a VR setting. Yes, and iMotions can definitely help with VR simulations as well. If you, Herman, I can see you were the question asker. If you are curious about how iMotions can help you with that, with inbuilt eye tracking in VR, just let us know. We're happy to help you. And then last question before we end is, does iMotions have any data sets or assist with building algorithms for human pose tracking? And I just want to qualify a little bit. David, maybe you have some input on this as well, but iMotions does not do any sort of AI component. So our software is built with signal processing in what's called our R notebooks. So all of our code for signal processing is actually visible in the software. You can load it, you can actually edit it in R if you want to change some sort of analysis that you're doing. But we actually don't enable machine learning within our own software. It's all entirely on the researcher to apply their own methodologies that are sound within machine learning algorithms, et cetera, to make the conclusions that that are relevant to their research. Because we're providing the software that actually is the data collection tool and the visualization and synchronization tool for data. And we do have some visualization tools. We have, for example, a webcam eye tracking algorithm that can show heat maps, for example, from webcam eye tracking for visual attention, but that is, you know, all of our analysis capabilities is then put onto the researcher to make the conclusions that may or may not involve machine learning. So in terms of human pose tracking, that would be up to you, the researcher, but we do have the data analysis capabilities to help you. Yes.
So what our group really likes about sort of that construct is our statistical training here on campus is all hung off of RStudio as a platform. And so our students go through a sequence in statistics that trains them on how to code and utilize analysis techniques in R. And so it's an easy transition for us. It's a powerful tool. We really like that analytics platform. We do a lot of our statistics with those libraries as well. So it was a nice transition for us.
Yes, great. Yeah, I love the R notebooks. I think it's amazing that we're able to supply researchers with that tool, because a lot of the other vendor software might have black boxes where you actually don't understand where the signal processing is being done, and you don't have the actual methodology that's publishable and reproducible, because it's going into a system. A black box is saying do something, and then you spit out the results. But iMotions, we're really believing in open source access, so you as a researcher can go in and use RStudio to manipulate the R notebooks and see the entire methodology for how we signal process. So yes, we have one more question, actually late to the game. In terms of transportation safety, where do you think future research will tend to direct? What should be the areas of focus on the future when we have eye tracking to solve transportation safety problems? And you have 3 minutes and then we have to stop.
Oh gosh, okay, so that's a wonderful question. The stuff that, so one space that I'm really interested in is non-motorized road users, vulnerable road users, and how we can design and operate infrastructure to promote that mode of transportation. I think it's significantly underutilized within US context, and there's a huge upside to mode shifts away from single occupancy automobiles towards walking and biking for trips that are viable. I think the introduction of e-bikes as a new and novel mode will increase the potential use cases for bicycling as a mode of travel, especially in dense urban environments. And so I'm particularly interested in applying human factors paradigms towards peds and bikes to better integrate them into as design users of surface transportation systems. I think that's an underserved topic, at least nationally, here in the US.
Mm-hmm. Yes, I completely agree. And the more that our infrastructure can support non-motorized users of the public space, I fully support. And I hope that your simulators can move that along. And I think it will. So on that note, we are out of time. So I want to say thank you so much to Dr. David Hurwitz, Professor of Civil Engineering at Oregon State University and director of the very interesting lab that you just heard about. So if you have questions for him or for us, you are welcome to email us at marketing@imotions.com or find his website, which is davidhurwitz.org. And you can also connect with us on LinkedIn. or send us your questions at marketing@imotions.com. So please reach out if we didn't answer your question or you want to connect with David directly. We're happy to make the connection. So thank you so much. Have a great rest of your day.
Thanks, everyone.
See you.